Hello guys, welcome to Surveying Solution, your number one channel where you get solutions to all your surveying problems. We are still on geodetic surveying, and today we are going to consider a spherical triangle. Don't mind my diagram. Alright, so today we are going to consider a spherical triangle, and then these are the parameters we are going to work with, or let's say the data we want to work with. And we've been given a spherical triangle, and we've been given the angles of the different sides. We've been given the different angles rather, and we've also been given one of the sides. And they said we should compute for the two other sides, and then we should also compute for the spherical excess. So that will be our task today, and I am glad to have you join me as we find solution to this surveying problem. So now let's go on. First off, this is a spherical triangle. It is not a plane triangle like the normal plane triangle. We know that the sum of angles in the triangle is equal to, or must be equal to, 180. Yes, but in this case, the sum of angles in this spherical triangle will not be equal to 180. There will always be a spherical excess. And now computing for that spherical excess will not just be adding the angles together and maybe subtracting 180 from it. No, there are formula you can use to compute for the spherical excess. So that's the foundation we need to lay, because somebody might just say, okay, why don't we just add the three angles? If they are more than 180, we just subtract 180 from it. Why can't that just be our spherical excess? No, the spherical excess must be computed for, and we are going to compute for the spherical excess E on this particular video. And if you look at the sides of this triangle, you find out that they are not straight, they are not plane lines, they are arc lines. And for arc lines, the distance, for arc distances rather, they must not be having values in meter. Their values must be like degree, minute and second. They must have arc distances, not maybe planar distances like in meters. So but if you look at this question now, the distance B was given in meter. Therefore, we are going to convert this distance in meter to its equivalent in what? In arc distance. So it will be a very interesting ride, and then I know we are going to get solution to this problem. Now let's ride on. First off, we are going to quote some of the formula we are going to use on this particular solution. So the first formula I want us to quote is the sine formula. The sine formula for spherical triangle. The sine formula for plane triangle is different from the sine formula for spherical triangle. The only difference is the side. As I told you, this side is not a plane side. Therefore, we are not going to treat it as such. So the first set of formula we are going to quote is the formula for what? The sine formula for spherical triangle. And this is given as sine A all over sine A equal to sine B all over sine B equal to sine C all over what? Sine C. So this is one of the formula we are going to use. If you look at it, our numerator and our denominator has sine, which means that we are dealing with angles on the side and we are dealing with angles on the angle. I don't know if this particular explanation got you confused, but it's just the simplest way I can put it, that the side is not a plane side, it is rather an arc distance. Therefore, we have it in degree, minute and second. So let's just forget about so many English. So that is what happens to side B and side C. So the small letter represents the sides, while the capital letter represents the what? Represents the angle. So this is the first set of formula we are going to use. And the second set of formula we are going to use will be the formula to compute for our spherical excess E. Now the formula to compute for our spherical excess E is given as AB sine C all over 2r squared sine 1 second, or you can use C squared sine A sine B all over 2r squared sine C sine 1 second, or you can likewise use A squared sine B sine C all over 2r squared sine A sine 1 second, or you can still use B squared sine A sine C all over 2r squared sine B sine 1 second. So these formulas are all equal to each other, just like the one we have for the sine formula for spherical triangle. This is the formula for spherical excess, and if you look at it, the result you get for this is equal to the result, or will be equal to the result you get for this, but the parameters are different. So now, depending on the parameters given or your choice of parameter will determine the formula you are going to use. If you look at this, we have two sides, we have one angle. If you look at this, we have one side, we have two angles, and we have the third angle here. So by the time we start applying the formula, and then maybe after going through the video, you want to use the other parameters to also check the answer, you'll find out that your answers will be the same. Then there is another formula to convert this our side here to a, what do you call it, to an arc distance, and there is a proof to that, but on this video we are not going to consider that proof. We are just going to extract the proof. We are not going to prove it, we are just going to extract the proof. And on that proof, it is said that 1 degree is equal to, we have 1, 2, 3, 4, we have 77.4734 meter. So what they are trying to tell us here is that 1 degree is equal to 1, is it million, or we have 1,111,177.4. It's not something we will now be trying to hit. So that's just the digression, by the way. So 1 degree is equal to this particular value here in meters. Now this proof was actually to convert this particular side or any side given to its equivalent in what? In arc distance. The angle suspended by a circle or so, but we are not really interested in the proof today. We are just going to extract the proof, and this is the proof. So we have a set of 3 formulas to use. That of the sine, let's say the sine rule for spherical excess, and for spherical triangle rather, we have the formula for spherical excess, and we also have the formula to convert our side in meters to degree, minute, and seconds. I believe that's just the clearest or the simplest explanation I can give to that. So having cited the formula we are going to use, or quoted the formula we are going to use rather, let's now commence our solution. So the first thing we are going to do is that we are going to compute for this b. We are going to convert it from this distance we have here to its equivalent in degree, minute, and seconds. That is what we are going to do. We are going to convert it from this 34046, its equivalent in arc distance, from plane distance to arc distance. So now let's now continue. We've been told that 1 degree, from the formula we are going to use, we've been told that 1 degree is equal to 111,177.4734 meter. And we have 34,046.930 meter. So what will be its equivalent in degree, minute, and seconds? We don't know. So now, how do we go about it? Since we've been told that this particular planar distance is equal to 1 degree, then we can get the equivalent of this also in arc distance. So let's now rearrange. So if 11,117.4734 is equal to 1 degrees, then 34,046.930 will be equal to, we don't know. So this is simple mathematics. What do? We cross multiply. By the time we cross multiply, we'll find out that we have, so if we now represent this with x, by the time we cross multiply, we'll find out that we have 11,117.4734x equal to 34,046.930 times 1 degree. I hope it is clear. Good. I heard your answer. You said it is clear. So how do we get our x? This implies that our x will now be equals to 34,046.930 times 1 degrees divided by 11,117.4734. Alright, so now let's go to our calculator and let's finish it up from the calculator. So we are now going to impute those values on our calculator. We have 3, 4, 046.930 multiplied by 1 degrees. So it's virtually giving us an answer in degree, minute, and seconds, which we have as 34046.55. There is nothing like this in mathematics, however, but let's just use it because we are not going to convert anything to another standard unit or whatever. So let's just go on with it. All we need is the value for x. So we now divide it by 11,117.4734, right? So we now have something like 0 degrees, 18 minutes, 22.46 seconds. This means that B we have as 34,046.930 meter is equal to 0 degrees, 18 minutes, 22.46 seconds. So this is the equivalent of this plane distance in arc distance. So that's the value for B. Let's now proceed to computing for side A and side C using any of these sign equivalents. So since we have angle B and since we have side B rather and we have angle B, we can easily equate B and A to find A. or equate B and C to find C. Whichever the case is just a matter of choice. But for the purpose of this video, let's say we have sine A all over sine A equals to sine B all over what? Sine B. So what are we looking for? We are looking for what? A. Therefore, we have to make this the subject of the formula. And by making this the subject of the formula, we have something like sine A is equal to sine A sine B all over what? Sine B. I hope it is clear. So now let's input the values of each of those alphabet there. So we have sine A. Our angle A is what? 86 degrees 3 minutes 8.44 seconds times our side B, which is the equivalent in arc distance. We have 0 degrees 18 minutes 22.46 seconds divided by sine B, which is the angle there. We have 50 degrees 01 minute 59.15 seconds. So we are now going to impute these values on our calculator to get the final result. So let's start with our numerator. Our numerator says we have something like sine 86 degrees 3 minutes 8.44 seconds multiplied by sine 0 degrees 18 minutes 22.46 seconds. We have this value for our numerator. So we just write it down somewhere on the next side of the paper. We have something like sine A is equal to 5.332170064 times 10 raised to power minus 3 divided by, we now get the value of, so let's just store this answer somewhere. We get the value for sine 50 degrees 1 minute 59.15 seconds, and this was given us 0.7644 156 251. Going further, the quotient here will now be, we stored this as A, the first result. So we say alpha A divided by this answer. So we have something like this. Therefore, sine A is equal to 6.957282563 times 10 raised to power minus 3. Our A, which we are looking for, will now be the sine inverse of this, which will now be equal to, so on our calculator we say shift sign, the answer, we have this. So the side A is given as 0 degrees 23 minutes 55.05 seconds. So this is the value for side A. On that same note, we are going to compute for the value for side C using the same process or the same procedure we followed through. So we are now going to equate sine B and what? And sine C. So we have sine B all over sine B equals to sine C all over what? Sine C. So on that same note, since we need the value for C, we are going to make C the subject of the formula, which then implies that our sine C is equal to, which is this, sine B sine C all over what? Sine B all over sine B. Now we are now going to what? Impute the formula into this the parameters into this formula here. So our B, the side B we computed earlier, was given as 0 degrees 18 minutes 22.46 seconds times the angle C we already have, which is this, sine 43 degrees 54 minutes 55.07 seconds divided by sine B, which is what? 50 degrees 01 minutes 59.15 seconds. So by the time we impute these values on the calculator, which we are going to do right away, we'll get our final answer. To save us the time, we are going to set the calculator on math mode. Yeah, so you press shift setup, then you press 1. This will give us the ease of having a fractional input. So we press this, we can now input everything once and for all. It saves time. So we have sine 0 degrees 18 minutes 22.46 seconds. We close that bracket, multiplied by sine 43 degrees 54 minutes 55.07 seconds. We close that. Then our denominator is given as what? Sine what? 50 degrees 1 minute 59.15 seconds. So we have the value for side C. We have sine C to be equal to 4.83700768 times 10 raised to power minus 3. Therefore, our side C will now be the sine inverse of what? Of this value here, which will now be on the calculator as shift sign, second function there, and then we have 16 minutes. So we have 0 degrees 16 minutes 37.71 seconds. So this is the value for side C. I hope you followed it up to this point, because we try to break down almost all the steps so that no part of it is missing, there is no ambiguity, and every part of it is very clear. So it's good that we've got into almost the last part of it. We want to compute for the spherical excess. So the spherical excess E, we are just going to use either any of the formula we have here. We have so many formula here. Okay, let's use this formula because all of them will give you the same answer. So if we have AB sine C divided by 2r squared sine 1 second. This will now be equal to, what's our A? The A we computed here is what? The A we computed here is 0 degrees 23 minutes 55.05 seconds times the B 0 degrees 18 minutes 22.46 seconds times sine C. What's our C? Our C is 43. Let me bring it up here. 43 degrees 54 minutes 55.07 seconds divided by 2 times the arrow we are given, that's the radius of the earth. We have 6370 kilometers. So if we want to convert it to meter, we have something like 10 raised to power 3 in meter. Then it is squared times sine 1 second. So we are going to run this through on the calculator once and for all to get the value for the spherical excess for this particular spherical triangle. So now let's go. We are still going to use the math mode. So I just want us to pay a very close attention to how the processes are going to go. So the first thing, we have 0 degree 23 minutes 55.05 seconds times we have 0 degree 18 minutes 22.46 seconds times we have sine 43 degrees 54 minutes 55.07 seconds. Then we come to our denominator. The denominator is a bit tricky, so you should just be very careful. We have 2 times, let's just say we will open a bracket here, 6370 times 10 raised to power 3. Then we close that bracket and we square it. Then we now multiply sine 1 second, multiply it by sine 1 second, which is sine 0 degrees 0 minutes 1 second. So we have something like this. So the spherical excess will come out as this. The spherical excess will come out as this. The spherical excess here is 2.152021404 times 10 raised to power minus 10. So this will be the value for the spherical excess. This 10 raised to power 3 here, we are going to do away with it, and we are just going to use this value direct. So let's cross this, and then let's edit the input on the calculator. So by the time we come down to this place, okay, so we would have something like 6370 squared. So let's see what we got here. So we got something like 215201404 times 10 raised to power minus 4, not minus 10. Pardon that error. So to raised to power minus 4. Therefore, the E in degree, minute and seconds will be 0 degrees 0 minute 0.77 seconds. So this was the spherical excess on this spherical triangle. I hope you really found solution to this particular solving problem we just dealt with this. Okay, today, whether morning, afternoon, night, that we just dealt with this morning, and I really wish you would comment if there is any question, and then if you've not subscribed, please subscribe to the channel, invite your friends to do the same thing, and I'll see you again on the next video. Until then, make sure you take your surveying career as a student, as a professional, very serious. Thank you very much.